want to push to get the most torque I can have to spin this wrench?
This is the second problem on physics review.
Adrian said it's on the end on the left. So he says right here. Somebody else said right here where the center of mass may be. Maybe I want to push here. Maybe I want to push here. Which one of those would give me the most torque? So let's look here. What would be the torque from this?
0.
Why is it 0?
There's nothing on the other side.
So this is 0 torque. What about this guy? 0, because this is the pivot point, right? So this is 0. You guys know what a wrench is?
Yeah.
Okay, just checking. So this is 0 torque. All right, now how do we calculate torque again? Force times distance from pivot point. So if I have my distance from the pivot point here or here, which one's greater? To the left? So which one's going to have a bigger torque? So this is going to be a torque, the biggest torque we can have. And let's just say this is halfway in between. I know that's not perfect. Let's say it's halfway in between. This will be half the torque. Everybody got that?
Even if it's long enough,
Yes.
I don't get the picture.
I don't get your picture right here.
That's not for this.
What is
Okay,
the
for the next
next
question.
Oh, you need to space this out.
I did space it.
No.
I was trying to. Well, I couldn't space it anymore because then it would kick the question to the next page. So I tried.
Okay, never.
Okay, I'll never next time.
What?
So the wrench question. Do we understand how this looks?
Yeah.
Now, do you think I'm going to ask you about a wrench? No, but I could ask you about a million different objects, couldn't I? I could say I have a rod holding from this pivot point. Or I could say that I use a door. And I ask you where to push on the door to have the most force. Or I could ask you about, I don't know, your shoe. If I wanted to take my shoe and stick it to the ground and I could spin the shoe or something. I don't know. Okay. I can use a table. Okay. So it's going to be an object that you're going to have to put the torques in order from least to greatest. You're going to have to understand what's the greatest torque and the least torque. Everybody got that?
Yeah.
Okay. Good. Next one is this cool drawing here. We got this drawing. We got this little thing here. This says like 8 meters or something like that. This says like 2.5. Right? So it says the uniform board, length 12 meters. So this whole thing is 12 meters. Mass 41.05 kilograms. Is just sitting there not attached. What does that mean? That means if I take 2 boards and I stick them like this and I stick another board across it and I don't hook it down, that's what that means. So it can flip.
What'd you say?
I'm so confused.
Okay. Okay. If I do this, will you hold this for me?
Look in the camera.
Will you hold this for me? Move it this way. Don't hold the top. That's what's going on right there. So it's not attached, right? So if I push too hard on this, what's gonna happen? It's gonna fall. What if I push on this side? It's gonna do. Okay. So everybody see the picture, right?
Yeah.
Oh. I didn't even know that was on. All right. So it's resting on there. A painter is standing on the board, moving back and forth as he paints. So the guy's standing on the board doing this and making sure he's painting. Everybody got it?
That's not safe.
Yeah, no, it's not. How close to the corner of A, so he wants to know how far this way he can go before it flips. So what's going on here? Yeah, we want to know how far away from the pivot point we can go before it flips, right? So, what's going to counteract that flipping?
The weight.
The weight on the other end.
The weight on the other end. What is the weight on the other end? What is this? Isn't there a weight for the board? Oh, the board? What is it?
41.05.
So that's the mass, right?
How?
Okay, so how far away where is the center of mass of this board?
In the middle.
In the middle, right? And the board is 12 meters long, right?
6.
So it's 6 from the end, right? So I'm going to put that here. 6 meters. Okay, now, is that the distance from the pivot point?
Yeah.
Where's my pivot point at?
6. Oh, 8.
Right here. Why is it right here, Alex?
Because like that's where that's what's like it's depending on that point to tip. Like if
Yep.
you're gonna,
So, like I showed you with the meter sticks, if I walk too far this way, it's going to flip from this side, right? So that's what it's asking about right there. So, how far away is the how far away is the board center of mass from the pivot point? How far is that?
3.5.
3.5 meters. So my distance here for my board,
Subtract 6 from 2.5.
my torque for my board,
You should subtract what?
hold on.
6 from,
Hold on.
2.5 from 6.
Y'all getting ahead of yourself.
No, we didn't know how you got that.
I didn't write it yet.
They said it.
I know. So, our torque from our board is going to be our force. What's our force?
41.05.
Times what?
9.81.
Times gravity. So we have our 41.05 times 9.81. Everybody with me on that? And we have to multiply that times our distance from the pivot point, which you said the end to here is 2.5. So to get all the way to 6 would be 3.5, right? Everybody with me on that? So 2.5, 3.5 more gives us 6. We're good to go. 3.5 meters. Multiply it all out, you get your torque from your board, right? Somebody want to do that on a calculator for me real quick? Tell me what it is.
1,409.45.
Mr. A, something happened with the board. Okay, what is it? 1,000 what?
409.45.
One more time because I suck at writing apparently. What?
1,409.45.
Okay, we'll do 4, 5. Okay. So we got this, right? Can our guy's torque be more than that?
No.
No. Can it be less?
Yeah.
So, as long as it's less than that, it's not going to flip, right? Once we pass to where it gets more, what's going to happen? It's going to flip over. So, can we set this equal to our torque from our guy to find out where he's at?
What's your torque?
Well,
His weight is 93.2.
it says our weight, right? So what are we looking for here, really? It says how close can he get to corner A? So what is that?
The distance.
That's the distance. So we're looking for distance, right? Okay. So we set this equal to the torque from our guy. Torque from our painter. Torque from our
What
guy.
is that, Coach Steve?
It got,
What, TG?
yeah, torque from our guy. TG. Torque from our guy. All right. So, how do we find torque from the guy? We do our force
So
times distance, right?
93.23 and 10.81 and it's like times that, I guess.
And the distance too. I don't know.
This is easy.
Times x, solve for x. Is that super hard?
No.
Pretty easy? Hardest part, recognize, oh, that's a torque problem. This is our pivot point. I understand now, we're good. You with me?
Can you finish this?
Yeah? You take this and multiply that. That's it. All right. When the painter is standing exactly at the point you identified, what is the weight being supported by the scaffold at point B? What? You just divide it.
It's 1.5.
What you divide?
You divide what you
See, Coach Steve, we confused. Everybody on
Oh,
the
from
same.
14.905.
What do you confused about?
Like
X is the distance. You can put D.
Alright, well,
Give me
that's
what
the
D.
answer
Yes.
to that whole question.
Yep.
that. You divide 14.
This divided by this.
Yeah, that divide by this.
Mr. A.
Right here.
93.
Easy technique.
Nah. That's math. That's boring math. That's easy algebra.
Some people have to write out.
It's easy
all the
algebra.
steps, though.
We don't need to write out every step for easy algebra.
Yes, we do, because when we take the test, we be wrong.
Oh my gosh. You can't do this algebraic expression here. If I said 10 equals 5x, we can't do that?
Hurry up.
Yes, we can.
So
Okay.
you guys just 1.5 away from
1.5 meters away, yep.
Copy, bro.
Stop.
All right. So, part B. When he is standing at that point, what is the weight being supported by scaffold B?
What?
What's scaffold?
What?
Yeah, what?
This is scaffold B. This rod right here.
Oh.
Is this holding all the weight up?
No.
Not all of it.
Why
The other
not?
half. The other
There's
half.
another one on the other
The
side.
left side doesn't matter because you're not over, the weight's not over.
Because we're balanced, is there a torque from this thing?
No.
No. So because we're balanced, is there any weight being distributed over here?
How you know we're balanced?
No. If I pulled this out, it wouldn't tip. It would just stay there, right? So this one has how much weight supported by it?
Half of the.
0. There is none. Why? Because we don't have a torque pushing down on it, right? Now, since these are both balanced on this point, where's all the weight being pushed at? From this point, right? So for the next part, it says, what is the weight being supported by scaffold at point B? You would just add up the two weights. So you would do your mass of your board plus your mass of your guy times gravity to give you your weight, right? And that's it. You just add up the two weights, you're done.
Can you write it down?
Wait, you
Yes, I
said
can.
mass of the board and the guy.
So weight of the guy plus weight of the board equals the answer. Weight of our guy is 93.23 times 9.81. I don't like this pen, Mr. A. It likes to write when I'm not touching the board.
Yeah, I know, it's very sensitive.
I don't like it. Plus the weight of the board, which is 41.05.
You add the two weights times 9.81.
So it's not mass, it's weight.
Weight. It asks for weight. That's for weight. And C is 0. All right, William. Mass of the guy times gravity plus mass of the board times gravity.
Oh, I did that one.
You could add them both up and then multiply by gravity. It's the same thing. Yep, same answer. Everybody with me on that? Kenny, you with me?
No.
Okay, let's talk about it. You ready? If I balance something on a board like this, and they're balanced, is all the weight being supported on this board?
Yes.
Okay, so if I put another one over here just for looks, doesn't matter, right? Because it's balanced, right?
Right.
Okay, so the only way that I could change that and add weight over here is if I move over here more, right?
Right.
Okay, so that's what's happening in this picture now, right? This guy is balancing out this guy, right?
Yeah.
So all the weight's being pushed down right here, and there's no weight being supported over here. I can kick this out and it'd still be fine because we're balanced like a seesaw. You with me?
Mm-hmm.
Okay, so
And Coach C is not the same thing when you do it the other way.
you just didn't put parentheses. So
I'm confused.
now, if we're talking about the weight on this board, or weight supported by this, we find the total weight that is being supported by this. Where are the weights coming from?
The guy.
The guy and the board, right? So, our weight of our board is this, times 9.81. That's our weight. This is our mass. That's our weight, times 9.81. That's this guy. We're going to add the weight of our guy. 93.23 times 9.81 to get our weight of our guy. Add those two up, we're done.
It's 1,372.
Okay.
Wait, what's the height?
Stop.
Oh.
You with me, Kenny?
Sure.
Weight of the guy plus weight of the board. That's it.
Why is C 0?
Okay. C is 0
There's nobody.
because there's no weight over here. All the weights being balanced here. If this was unbalanced, there would be a weight here, right?
Isn't that what you do with the practice? You said it don't have like less matters, so only
Correct. Are you with me? Anybody confused? Speak now or forever hold your peace. All right. Moving on to the next question.
No, it's not in pounds.
All right. The mobile pictured below in Figure 1 is in a state of rotational as well as translational equilibrium. What does that mean? It means it's not spinning, right? It's like ours, we're just sitting still, we're chilling, right? Please study the figure, then answer the questions that follow on your paper. Neglect all weights of the bar and the string unless the problem directs you to do so. So that makes it easy for you, right? You don't have to worry about the bars, right? Okay. This artist constructed a mobile out of tiny uniform bar pieces of string in various geometric shapes. The objects labeled A have a weight of 49 newtons. It told you the weight, not the mass, right? Straight down. The objects labeled B have a mass of 3 kilograms. So what do we got to do with those?
Divide by, wait, you can divide the weight by negative 9.81 to get the
Yep.
mass.
Mr. A, would you do me a favor and pull this picture up?
Yeah.
From that sheet? That way it's easier for me to explain it so that I don't have to try to draw it.
This one right here?
Yep, can I write directly on it? Is that possible?
Yeah.
Cool. Beautiful. 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 Okay. So, we got this guy going on, right? It says that A has a weight of 49 newtons. So this is 49 newtons. Where's A? This is 49 newtons. This is 49 newtons. Everybody with me on that? Okay. Now it says B has a mass of 3 kilograms. What do we got to do to that to make it a weight? Multiply times
9.81.
9.81. So we're going to do that off to the side over here. I'm going to write this. B is equals 3 times 9.81. Which equals what?
49.43.
Okay, so this is 29.43. Is there any more 29.43s? Is that it? All right. Now, what is the strategy to solve out the torques? What did you do when you built your mobiles? Where do we start at? Start at the bottom. Every time we do this, we start at the bottom and we work our way up. Why? Because we can't find the torque on this until we know how much weight is here, right? Okay, so, everybody with me on that? How will we find the torque of this guy, or the weight of this guy? How will we find it? How will we find it? Is this equal to this?
No.
We have distance.
We have distance, weight, we have distance, and we're missing the weight. Are these two torques equal?
Yeah.
So can we just set them equal to each other and solve?
Yeah.
Okay. So, Mr. A, could you go back to the blank screen? I don't know how to get there from this. Okay, beautiful. Oh. Okay. Awesome.
You go to the one you just did?
No, that's perfect. Perfect. All right. So, we have our torque from the right side. So we're going to call it torque from A. And we're going to make it equal to our torque from C, right? So go ahead and start solving this. See if you can do it without me. I'm going to start writing it down. See if you can do it without me. See if you can do it without me. You should be able to. It's just like our practices that we did.
I was not paying attention. Where are we?
How do I see?
It's daydreaming.
Wait, is it 49?
It's 49.
What's the torque for him?
Each is your word.
That's not mine. This one.
Mine is done up here if you want to look up here and see if you did it right. At least set it up right. I didn't finish the math yet. Did everybody get this?
You have to put it in meters.
Yes, you have to put in meters, always.
Is it in meters?
No, it's in centimeters.
It was just more decibel.
So we don't have to translate,
Meters or centimeters? Probably. Probably. Why? Because I want to see if you're paying attention.
How about grams to kilograms?
You only lose a point if you don't. Still a point. So you take this times this, divided by this. What do you get?
19.6. I get 0.
What'd you get?
I got 19. Did
you do it meters? Yeah.
Yeah.
You got 19.6?
Yeah.
What? How? I got 1.9.
How you calculate?
That's 4.4 times 49 equals 11.76. Yeah, I got 19.6.
Me too. What'd you get, Tom?
I got 19.6.
I got 19.7.
Taylor, you probably did you use 0.24 or regular 24? 24.
19.6. Good.
You probably
That's it. All right. So from there, the next part says, what is the weight of object D? So do we understand how to get C? Okay. What is the weight from object D? Well, what do we got going on here?
Same thing. Where is D at?
This is gonna be.
I got back cancer.
Okay, so, great question. What do we do when we have stuff hanging from a rod?
You add them together.
Add them all up, right? What do we got hanging from this line? Let's look. We have 49 right here, right? Plus 49 right here. Plus 19.6 right here, right? So can we add all those up?
It's 117.6.
What?
Wait, what? Is it newtons or?
Add them up.
Newton?
I know.
It's 117.6.
What?
117.6.
Add all these up? Okay.
I'm sorry, I couldn't hear you. Probably speak up. I'll speak up next time.
Got her ass.
Wow. The weight of.
It says there that we are neglecting all the weights of the bars. So you don't have to worry about that. Good question, though. So he asked a great question. He said, what is the weight from bar K? It says in the problem you don't have to worry about the weight of the bar. So because of that, you can ignore that. If this was our real thing, we had to add that in, right? So great job. Way to pay attention to that. On the test, I believe I gave you, I just said don't worry about the weight of the bar. Just worry about the weights to make it easier for you. Okay? So, we got this guy hanging from this spot. We got this guy hanging from this spot. And we got this guy hanging from this spot, right? How will we set up our torque equation? How will we set it up?
We have to do the combination of the bottom one
So this
times 0.6
times 0.6
and
plus
that one
this
times 0.2
times 0.2
equals
hold on, equals
0.8.
0.8 times D. Okay, so in case you missed it, you ready? I'm gonna explain it, Chris. You ready? This whole thing that weighs 117.6 newtons is getting pulled from this spot. Would you agree?
Yep.
What is that distance away from the pivot point?
40.
40 is from here to here.
60.
Well, that's not labeled.
It's labeled from here to here.
No, because the number isn't labeled as from there to there. I thought it was from there to the pivot.
Well, here's the deal. If that happens on the test, you can just put based on drawing, and I will give it to you. Okay? But that doesn't happen on the test. Okay. But so
How do you really feel about it?
0.6 times 117.6 is that torque, right? Plus this times 0.2 is that torque, right? And that's to equal this 0.8 times this weight, right?
Can you write it?
You said it has to
I
equal that?
can't. It's hard to. I'm gonna have to ask somebody to write it down, and then I'm gonna have to copy it up.
How do you get equivalent for B?
He said,
How did I get 117.6?
Add all them
You said 117.6 times
20 plus 40 is 60
What are we trying to find?
70.56.
because it's only 0.2 away where the bar is.
That's like the
29.
almost that we have.
Yeah. So look. This is 20. 40 more is 60. It's 60 away. And this is 20 away.
Can you label it better on the test?
I will. It's already been labeled as a test paper. This is just old homework that I used to use.
Where'd you get 0.2 from?
Huh?
0.2.
Right here.
This is 20 centimeters.
I thought you added them.
You said we gotta set that
Oh,
equal,
that's
right?
because this is
So
how
we
far
gotta
away
set it
it is
equal
from the pivot point.
to the
You're basing it off
Yep.
of how far it is.
So this is how it should look.
Anyways, it is away from this point. That's 20. That's 60. But I thought you added them up right here for the first part. So you multiply this by. That's only for this one because this one's 0.6. Oh, just for this one.
This is how it'll look.
Yeah, but for calculating B, you use 0.2.
I got the answer.
Do you plus them or do you multiply? The 2A and the 2B, I mean TB.
I got 95.5.
Did you add or multiply?
I did everything.
I got that too.
Did you add or multiply?
You gotta add them first, and then you divide by 0.8.
What?
So if you add those together.
So you guys.
What happens if you add together first?
You're supposed to
And then what should after that?
And you divide the sum by 0.8,
divide
right?
that by 0.8.
Why would you divide by 0.8?
Because
All right.
that's what you're looking for D.
So this is what we got.
On the pivot.
0.6 times 117.6. We all see how I got that.
Yes.
Plus 0.2, which got really messed up when I was trying to write it. 0.2 times 29.43. We got that? Equals 0.8 times D. We got that? All right. We good? From there, it's just math.
95.6.
95.6.
Hold on, wait. How y'all getting that?
Y'all making it hard.
That's what I got.
Bro, I don't know what the fuck you saying, bro.
Plus, negative, times,
Point is a decimal.
Yep.
that looks like a decimal.
If you pay attention, you know
No,
it
it
made.
looks like a negative.
Okay.
Multiply
Pay attention.
29.43
Well, he didn't
times
write.
0.2.
Wait, then what do we do?
It's never hard. It's mental math right
It's
here.
his writing that makes it hard.
It's just these words that complicate everything.
Complicated.
Words.
We didn't
How about, like,
learn
problems?
vocab.
Oh. Well, guess what? There's one identical to this, only it has fishies on it.
What am I doing wrong with the
So,
Look, this look.
use
Look,
this.
look, look. Forget the calculator. Just
I'm
write
not
it
a man,
out.
but look at my calculator.
Alright.
all
Write
right.
them all up like this.
Does everybody got this concept?
Slow down. Yeah, do it.
What you got, Julie?
I got 76.44.
You just are messed up on the math. It has nothing to do with the physics. You set it up right. You just can't put it in your calculator right? Right?
I thought.
So you better get a better calculator for tomorrow. Okay, we use it. All right.
Put it in front.
Coach C, wait up. Hold on. So,
That's why.
So,
You got 7.
I will tell you this.
Drink some.
For the next part, it says, what is the mass of object E?
oh yeah.
You don't have to do that on the test where you have 2 of it and you're trying to figure it out. That's for this to see if you really understand what you're doing. So I'm not going to go any further with this problem because it's just the same stuff. We're just writing all the torques and we're making sure they're equal on each side. Okay?
E.
What you need to take away from this, you need to take away that we do force times distance away from the pivot point. And you need to make sure that you know that both sides are equal to each other when you add them up in torques. And finally, you need to understand that when we have something hanging, we need to add up all the weights, and that's the torque from that spot. Those are the takeaways from this. If you understand that, you can do well in this problem. Yes.
How are you supposed to find the length of the bars?
It tells you the numbers always.
No,
it's
I'm
always
talking about D and E. It says
Oh.
find the length.
So that would be, you have the mass now, and now you're just missing the length. So it's the same thing, only you have a different variable.
So if you have, what's the difference between mass and weight?
Mass and weight. Mass is just the mass, and weight is the mass times gravity. Yes.
Would that mobile like even work? Because like A is like 49 newtons, but then like the entire rest of the thing is hanging off the other end.
This? Yeah. This will be heavier.
No, I mean like at the top.
No, at the
like,
very, very
A,
top.
This?
It's the only thing holding that side over.
Yeah. So look, you see how this is 200 centimeters?
Yeah.
This could be 2. We don't know.
Okay.
It's a good thought. All right. So does everybody understand the ideas behind this?
Yes. Kind of.
I'll do another example.
Just
Because
bring
to
it
do that,
back.
we have to solve E and then 4 minutes. All right. So,
Always playing with my bank account.
Mr. A, it really doesn't like me. It doesn't like me. All right. The next question is this.
Clear everything, Coach.
All right, we got this guy. If the mass on the right is hung at the 70 centimeter mark, what is that distance? If this is hung, this is a meter stick hung from the middle. If this is hung at the 70 centimeter mark, where is that at? 20. 0.2.
Because it's hung from the very center.
Oh.
He's about to zone me out. Okay.
Yes, it is.
Wait, hold on. I do have a question.
Yeah.
I'm slowing down.
It's not funny, Coach.
This is a meter
Okay.
The meter stick is
I
hung
take
from the middle.
You're wasting time. We got 3 minutes.
The middle is at 50 centimeters.
That's what I needed. That's all I
We
needed.
hang a mass at 70 centimeters. We are going to find the torque of a 100 kilogram mass. 70 centimeters. How do we do it? We find our torque from our big mass equals our torque from our small mass, right? This guy and this guy are equal to torques. Right? 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 Okay.
Honestly, oh.
So, torque for our big one. We have 100 times 9.81
Bruh.
times 0.2. And that's going to equal or this one. How far is this away?
20.
No, this one ain't 20. What is this one?
Oh.
This on the end.
50.
50. 0.5. 0.5 times 9.81 times our mass, right? And we just find m. And we're done. Just
Wait.
divide it.
Times our mass.
Yeah, because that's what we need, right? Force, 9.81 times our mass. We don't know this mass. That's what we're finding. That's what it asks for.
You have to set it equal?
Yeah. That equals that. So, that's pretty easy to set up, right? The math is the only hard part. Okay, last question. This is a thought-based question. Last question. If I want to perform a backflip, is it better to do it with my legs straight out or my legs tucked in?
Tucked in.
Why?
Because
It brings
Break
your
your
center of
dog.
gravity.
So, the closer that my center of mass is together, the less rotational inertia I have. The less rotational inertia I have, the faster I can spin, right? That's the last question on the test.
Say it again.
The closer your center of mass is, the less rotational inertia. The less rotational inertia, the faster we
Hold
can spin.
on. Closer center mass, what?
44 degrees.
Center of mass.
One thing I want to mention about math review guide.
Go see. Go see.
Every single little step. So it seems like a lot of writing, but just know you really don't need to show that many steps. I just want you to see these kind of separate steps so you understand how to solve the problem. Let's review guide what we're going to
What do you say after the last question? The closer we center of mass, the less it is.
Let me know. I will help you.
Everything in the center of mass becomes more compact.
have a great day.
The faster you spin.
Yes, you got 40. Well, you talked about to get a good one. Wait, you got 40?
Yeah, I got 40.
Faster what?
You spin.
I'm a $1 day.
I know today, but every day.